Hello guys and welcome to the DevopsGuy channel. In today's video, we will deep dive into Amazon VPC. We will be accomplishing these tasks by the end of the video. We will create a new VPC. We will also create new subnets inside the VPC. We will be creating additional route tables in the VPC and attaching the newly created subnets to it. We will also create an Internet Gateway and a NAT Gateway, and we will add the routes for it in our route table. Let's get started. AWS VPC, or the Amazon Virtual Private Cloud, lets you create a logically isolated section of the AWS cloud wherein you can create your own custom resources provided by AWS. VPC allows you to have greater control over your networking. You can have your custom subnets set up along with the custom IP addresses. You can also logically isolate your different subnets. Let's move on to the VPC management console. As you can see, these are the VPC services offering provided by AWS. You have the VPC, then subnets, route tables, internet gateways, Egress only internet gateways, which is nothing but IPv6 internet gateways. Then we have the DHCP option sets, elastic IPs, then your VPC endpoints, endpoint services, NAT gateways, and the VPC peering connection. Let's check them one by one. So if you see, there is already a VPC created by the AWS. This is done for every new account. This is called the default VPC. As you can see from the tenancy default, and the default VPC is set as yes. So this VPC is given to you as a bootstrap set of resources wherein you can directly go and launch the AWS resources in the VPC unless you want to customize it. And you can see these are the VPC properties. Everything is already set up for you in the default VPC. One thing to note here is that if you delete the default VPC, you will have to ask Amazon to recreate it if you want to use it in future. Let's try to create our own VPC. This is the name tag. We will name it VPC-1, and this is the tenancy tag. As you can see, there are two tenancy settings. One is default and another one is dedicated. Default is the shared tenancy. This is basically the tenancy wherein your AWS resources will be running on shared hardware. You can also opt for the dedicated one. The prices for that will be more, but you can be assured that no other customer will be given your hardware to be shared with. This is required for some of the government services and a few of the compliance. We will go with the default setting. This is the IPv4 CIDR block which you will allocate to your VPC. It has to be a 16 subnet or wide enough to accommodate all the subnets inside it. We will not create any IPv6 CIDR blocks. Let's create the VPC. So our VPC is created. Let's go and check the VPC service now. As you can see, our VPC-1 name is already created. The state is available, and you can see the other settings. There is a network ACL by default created for it. There is also a default route table and a default DHCP option set already created for it. Let's see the CIDR block. So on the CIDR block, this is the primary CIDR block that we have created with this VPC, but we can add more CIDR blocks in future if you want, and both the CIDR blocks should not be overlapping. That's the one condition to create and add more CIDR blocks to your VPC. We don't have any IPv6 CIDR blocks right now. Okay, so from here you can edit the settings for the VPC that is created. This is the flow logs which help us capture the traffic flow within our VPC. We can create as many flow logs with custom filters and rules. And this is the tags for the VPC. We have already tagged it as name. So these are the VPC settings. Let's move on to the subnet part. As you can see, there are three default subnet created for the default VPC that was given to us by AWS. We will be going ahead and creating our own subnets for our own VPC. Now, one thing to note here is that we should be creating as many subnets at least as the number of availability zones that we have. If you want to know more about availability zones, you can have a look at the EC2 video by the DevOps guy. And let's try to create the subnets here. This region has three availability zones. Let's try to create our subnet. Let's name the first one as subnet 1. Select our VPC, VPC1, and our availability zone we can select as AP South 1A. This is the VPC CIDR, and we have to create sub blocks out of it, as you can see, and these should be non-overlapping. So let's go ahead and create a subnet with 10.1.1.0/24. We will be creating subnets in this range now. Let's click on create, subnet created. And as you can see, subnet 1 is created. You see the properties here. 251 is the available IPv4 addresses that we get with it. We also have the default network ACL attached. It is in the availability zone AP South 1. There is no outpost ID here. Outpost is nothing but a device which sits on your premise and through which you can connect to the AWS VPC over the VPN network provided by Amazon. This is required in order to connect your on-premise resources or on-premise disks to AWS VPC. This is the CIDR. We don't have IPv6. This is the default route table to which our subnet is attached. We don't have any flow logs. Yes, we can have flow logs on subnet level. This is the main route table. Network ACL, the default one attached to it. Tags, and this is the sharing. We can share the subnet with another AWS account, but we will not be covering that here. Let's create another subnet, say subnet 2 and same VPC. Let's click on 1B now, and this CIDR should be 10.2.0.0 by 24. So we should be creating as many subnets at least as the availability zones available in that region. This gives us more choice when we launch our resources in the VPC as well as the high availability. As you can see, all the settings are nearly the same except the name of the subnet. Let's move on to the route tables. As you can see, there is by default a route table created for the VPC that we had created. We will be creating additional route tables. So by default, this is the route table provided by Amazon for the default VPC. As you can see, it has got routes with the Internet Gateway and for the local traffic, and the subnets are still not associated. Okay, so this is our default route table created when we created our VPC, and as you can see, there is only one route here for the VPC itself. And you see there are no subnet associated right now with it. We have to manually associate the subnets. No edge association, route propagation is set. No more tags. Let's create the route table. Let's name it public 1 because we will be creating a public route table here. Select the VPC and click on create. Route table created. As you can see, only the default route is there, which is for the entire VPC, no subnets associated. We will try to associate the subnets here, the two subnets that we created, subnet 1 and 2. So this will be part of our public route table known as public 1. Rest all things being the same. Let's create another route table, name it as private 1 and create it in the same VPC. And we will have to now create two more subnets to attach to it. Although we can attach the existing two subnets, but then we really want to distinguish between the two subnets. Let's quickly create the subnets. Subnet 3. There goes the second one, subnet having 4. Now we have 4 subnets. We will attach 4 and 3 to the private route table. As you can see, only 1 and 2 are still attached to the public 1 route table that we had created. Let's add the other 2 here. Okay, so now we have our public and private route tables with public and private subnets associated. As you can see, the default route is there. And now as you can see, it is not the main route table. So your VPC need to have a main route table. So what we will do is we will make public 1 as the main route table and delete the default route table that was created, which does not have any subnet association with it. Let's go and delete the route table. So you see the route table are main and cannot be deleted. So first we will have to set the public 1 as the main route table. You can see set main route table entry. We'll click on that. Confirm. Okay, now we can delete the default main route table, which is not main right now. Delete this table. So now we have two route tables in our VPC, public and private, with two subnets each, and the main route table set as the public 1. So this is where the distinction of public and private subnets come in. This is a well-known question, as in what is the difference between the private and a public subnet. So on a subnet level, there is no difference, but when it comes to the routes, your public route table is connected with an internet gateway, which has direct access to internet with the public IPs, while your private route table is attached to a NAT gateway or has a NAT gateway route, wherein all the traffic which is going out of your subnets is NATed using the NAT protocol, and the incoming IP to other services is seen as the NAT gateway IP. So let's create the Internet Gateway now. As you can see, this Internet Gateway is created for the default subnet provided by Amazon. It doesn't have much details, just like an appliance. Let's create a new Internet Gateway. Let's name it VPC 1 Internet Gateway 1. You can attach as many internet gateways as you want to each of the subnets for load balancing. We will also be creating a VPC tag to it just for our use case. Create the gateway, and the gateway is created, and you see the state as detached. We will have to attach it to the VPC. You see the VPC ID column is empty. Let's attach to VPC and select our VPC from here. Attach the internet gateway, and now you see the state is attached and VPC ID is showing the VPC1 ID. So now that we have attached the internet gateway, let's go back to the route tables and add a route to the public route table. Edit the routes here and add a route. add an entry for any traffic, which is 0000/0, and select the Internet Gateway from here, and it will prompt you the Internet Gateway for the VPC. Save the routes, and this is what it looks like. This is the public route table now, and the subnets which is attached to this public route table are now the public subnets. So whenever you launch any resource in the public subnets, it will be getting a public IP, or you can attach an elastic IP to them, and all the traffic outside will be traversed through the Internet Gateway that we have. Egress only Internet gateways. This is for IPv6 instances, or when you are using IPv6 addresses in your VPC. We are not using that, but this is just a distinction given by AWS. Let's move on to NAT gateways. So we will be creating a new NAT gateway. We will have to first select a public subnet in which to create a NAT gateway. NAT gateway basically NATs the traffic, or in simple terms, it takes the traffic from your private subnets which do not have internet access and which are trying to access the internet, and it traverses the traffic through your public subnet. But the advantage with the private subnet using a NAT gateway is the traffic is only outbound. So using the NAT gateway IP, you cannot connect to your services inside the subnet or inside the VPC. For that reason, we use public subnet with an internet gateway, which have got their own dedicated IPs. So let's go ahead and create a NAT gateway now. And yeah, NAT gateway needs an elastic IP address as well. So first we will be creating an elastic IP address. Let's allocate an elastic IP address from Amazon pool of IPv4 addresses. Click on allocate. We have got our elastic IP address. Now we will be creating a NAT gateway and be attaching this IP there. Select one of the public subnets, subnet 1 in this case. Let's add an elastic IP as well, which we created, and let's add a tag here, name tag. So our NAT gateway request has been accepted. Yeah, it says you have to add the route entry in the route table. So you see the status is pending. It will take some time for the NAT gateway to spin up and getting allocated to our VPC. Earlier, AWS used to provide us with NAT instances, wherein we can launch our own AWS instance, which can act as NAT gateway, but the solution was not scalable. So now they have given us a scalable service known as NAT Gateway, which is managed by AWS and which can be used for netting the traffic between your private subnets. You also have monitoring set up with your NAT Gateway, because in the backend it is basically an instance running. You can watch all those metrics in CloudWatch. Let's go back to the route tables and add an entry for NAT Gateway. Add a route in the same 00, and instead of Internet Gateway, this time NAT Gateway. So now our private route table is also set, and both the subnets in this private route table are now a private subnet. So this is the basic difference between public and private subnets. As you can see, the NAT gateway is still in pending state. It will take some more time. So our NAT gateway is available now. This completes our session for creating the Amazon VPC.